get going. Folks, just feel free to send a chat message if there's anything wonky with the sound or anything else, and I will go to it. Otherwise, we're going to go into playing this. Gary is on deck to answer questions, so feel free to use the Q&A chat feature to ask questions as we're going through. And if you want to save something for the end, we should have time as well. Marcel, Raja, anything else you want to add? Or Gary, anything else you want to add?
No, I'm excited to learn more about Tremor RS, not JS.
Can you hit the full screen option?
I will, yeah, absolutely.
Oh, cool. Okay.
All right,
Wait,
so here we
go.
Yeah.
Can I quickly ask what RS stands for? Like, what's that domain extension?
That's Rust. So typically when people are starting their Rust projects, they'll do .rs instead of like .js is actually, I think, a good lead on that people did that for a while. So Tremor is a completely Rust-based project, and so tremor.rs.
Cool.
All right, here we go.
Welcome everyone to Live, Laugh, Log. It's a whimsical dive into the workings of Kubernetes and Tremor at the scale of Wayfair. I promised that the jokes peaked when I named the talk, and they'll only go downhill from here. I'm Gary White. I work for the Open Source Program Office for Wayfair. I work with the team both on source code and advocacy for Tremor. I'd like to start this presentation by noting what this talk is intended for, what it explicitly cannot or does not accomplish. This talk is going to center mostly on Tremor, with Kubernetes as a background actor. I've tried my best to create broad appeal in the story and share nuggets of knowledge that interest as many of us as possible. All of our anecdotes and framing info will be coming from a place of Wayfair-specific expertise. That means e-commerce at an enterprise scale. We're going to dive into a scale that may not exist in most production systems, but it is my hope that this hyperbole of what your environment might look like projects well from an e-commerce company to whatever might be your expertise. I've also made an effort to avoid disclosing anything that might be a trade secret for Wayfair. If you're here to learn our secrets, you can stop the talk now and email me instead. I take bribes, no lower than $3,000. I will be able to give scale approximates and use online calculators to give an idea, but note that these are not exact representations and cannot be precisely communicated from inside the company to outside the company. What this talk is targeted at is entry to mid-level engineers that may have used logging tools or at least have heard of them being in use. We will not dive deep into any specific implementation or source code snippet. This is very much a dive into the experience at Wayfair that led us to build and use Tremor, not a dive into the implementation itself. So let's get into it. We all know that logs provide vital information to understanding our applications and health. And too often that cost is considered part of running the heavy machinery, and unstructured data is notoriously difficult to work with. Something I've learned from a lot of companies, and sometimes something I've learned from logging tools, is that most application logs are a fire hose. There's so much information that could be useful for debugging that comes from so many hosts or so many services that it becomes impossible to parse it. Not with your eyeballs, not with filtering tools, and especially not if you care about missing something. Since you came to this talk, it shouldn't surprise you to know that this is something that we started dealing with early in Wayfair history, and at the time we decided to go with a industry standard ELK stack, ELK. Oh, I'm sorry, this is obviously the wrong slide. Those are ELKs, and they're in a stack, but we're talking about a different ELK stack. Okay, this looks like the right one. You can see that the ELK here are able to read much more logs than any one person could. By stacking them together, we can read approximately 20 mid-size oak trees. Okay, hold on a second. No, this is still, nope, wrong. Okay, ELKs can't read. I've just checked my notes. ELKs can't read. So let me try the next slide instead. Okay, here we are, ELKs. My joke is so original that the Elastic site did it, and they did it with a better art department. But let's dive in anyways. The Elk stack under the business unit Elastic started with Elasticsearch. That searching tool was so fantastic for sorting through unstructured data that it expanded into a full solution for visualizing, ingesting, and searching through relatively unstructured data. That's how we got the ingestion engine Logstash, takes in the raw information, and the visualizer Kibana. And with this stack, we can both real-time and time series relate our queries in data. I suspect some or most of us have found logs with Kibana dashboards. What you may not have known is that the front end interacts with that entire stack to ingest and search through your data. At Wayfair, we lived happily with the Elk stack for a really long time, and we were so happy with it that we put log after log after log into it. It's a little tough to visualize how much data that is, but I'm a daring person, so let's try to give it away with some sophisticated visuals. Get it? Sophisticated? We're going to use this cat. I found this image while I was looking for pictures of logs for this presentation. Apparently, if you search for transparent log, this is what you get. So we'll pretend that this cat is a log. It'll be easier to remember the cat if she has a name. So we'll call this cat Log, and she makes us laugh as we live, Log. She's very funny. Log is a healthy cat, and she can hold quite a bit of data. In fact, Log holds an entire terabyte of logs. She's a big girl, and I think they say on the internet that she'd be a chonker. A terabyte is a lot of data, and Log handles it. Wayfair, not too long ago, were using the Elk stack entirely for our logs, and we were processing so many per day. Around, you know what? I want to make sure that we all just actually have an idea of how much a terabyte of plain text actually is. A single page of regular text on regular size paper is about 2 kilobytes worth of data. So 2 kilobytes of raw text is about a page. Online recipes can get up to like 50 kilobytes, but if you slim down to just the actual recipe instead of the story and the life habits of the person who made it, then you can get it down to about 4 kilobytes. If we want to figure out how big a terabyte is in relation to that, we will have to go down the stack from terabytes into gigabytes into megabytes to get down to kilobytes, and then divide by 2 so that we know how many pages of data we actually have in a terabyte. So let's do that. We'll start with a terabyte, or one princess chunk, our cat there, and we'll multiply by 1024. So we have 1024 gigabytes in a terabyte. We'll do that again to get megabytes, and then we'll do it one more time to get kilobytes. That gives you 1,073,741,824 kilobytes per terabyte. So we'll divide by 2, since remember our page of text is 2 kilobytes, and we get 536,870,912 pages of text in a terabyte. That's a lot of paper. It's at least one tree, I think. I have that written. Yep, it's at least one tree. In fact, if you had 10 terabytes of stacked paper, that is tall enough that you can reach the International Space Station, because one of these stacks is 33 miles or 54 kilometers. And when you get to the space station, you can amaze them with your balance, your paper stacking, and maybe pick up some origami while you're up there, because how else are you going to get down than by throwing cranes into the atmosphere? So now that we have some real-world interpretation of how much data is in a terabyte, remember, that's how much one log holds. One of these little kitty cats. So how many terabytes were we processing at Wayfair per day? We were processing about 5 round trips to the ISS every single day. About 100 terabytes. That's how much logs we pushed through Elk, and that works to about 3,000 terabytes a month. Little Log had a litter on us, and we had to scale our infrastructure to handle the cute little kittens, the chunky, sweet little babies that they are. And we were in a spot that many little companies, businesses, and engineering organizations find themselves in. We had a lot of data. The good news is, Elastic, Logstash, and Kibana were more than capable of handling that much input. The enterprise scale ingestion, the search, and the logging, it was built for it. But the bad news was that the operational cost that we incurred was particularly high, especially as it related to data ingestion and Logstash. I want to remind everyone, especially if you think I'm giving away Wayfair secrets for free, again, I take bribes, that I'm using a rough set of numbers here to paint a picture. This is not a detailed account of Wayfair. Logstash was chugging through about 3,000 terabytes per month. And that ran smoothly so long as we gave GCP a humble offering of, 100 nodes, all running with 16 CPUs each. If this wasn't a recording, I would assume that some of those in the audience would be shaking their heads or rubbing their faces in despair as they predict the cost of 100 nodes at that spec. We spent about $40,000 a month. That's a lot of money. You could buy a new car with that. You could buy approximately 40 cats, maybe 80 cats, or that's like a fifth of a ticket to space. So instead of stacking paper, we could fly by and show off our origami to the International Space Station with a half year of how much we spent on this infrastructure. Obviously, for a business of our size, the cost is justified. The ability to debug applications and read the signals that developers build into their infrastructure is critical to understanding the health of our business. And while we could have accepted this as a cost of doing business, we had a team that decided to look a little deeper. It's relatively easy to look deeper, given that Logstash is on GitHub and the software is open source. As we combed through, we noticed that there were some implementation choices that made us wonder if there was a better way. Namely, we were interested in Logstash's choice to be written in Java. Java uses a JVM, and the virtualization layer between resources and applications can cause some bloat as applications get bigger. It also compounds exponentially when you're talking about data tall enough to reach outer space. Every request that's slowed down slightly expands as the scale expands. Logstash was also built to be compatible with many other systems. That's normally a value add and an asset at small loads within most companies, but we were talking about literally thousands, hundreds, and thousands of terabytes. And the trade-offs that can be made for systems supporting lots of ways in and out versus a specialized processing pipeline made us consider building something for ourselves. We suspected that building something for fewer use cases and maybe using a more performant language could bring us some value. This was the beginning of Tremor. The first question that we had when we set out was, well, what would that look like? What should we build? To replicate what we came to expect from Logstash, we needed three central pieces of the application. First, we needed a set of on-ramps from several places. Generally, this comes in the form of HTTP and HTTPS endpoints, but it might also be from OBDC connections from databases. It may be from Kafka topics, but we needed a way to get data into Tremor. Second, we needed to be able to process data when it's inside the application. And this might be querying for fields, identifying the data differently based on a host name, blocking data from applications, fingerprinting requests. And we might even identify that multiple off-ramps could be valuable for a given event or log. Our downstream services may want to be notified of specific events. Sometimes we may want to split one request into many downstream processes. And generally, we don't want to send one log with all of its data everywhere. We only want to send the necessary data to each of those consumers. So we have our on-ramps, we have some processing. And lastly, we have the ability to send data out to other systems, off-ramps. This could also be a Kafka feed, HTTP, HTTPS endpoint, GCS bucket, or an ingest to store the data where Kibana, Grafana, or Elasticsearch even can get to it. Note that if we identified the data as something that should notify other systems, we may send the same information to many systems. We suspected that this tool could be useful to extend, so the architecture was molded after the ability to plug in new on-ramps and off-ramps as code. And then folks using Tremor would be able to extend it to their needs. What you're seeing visualized here, input, process, and output, is what we built Tremor on. There's another very important feature that we needed in Tremor that we were unable to make use of in Logstash. To understand what that was, let's take a look at a real use case to understand it. Ingesting from Nginx. Do we remember our fire hose example from earlier? This is it again, and I just love this GIF, so I had to use it some more. Imagine that you're running an e-commerce site, and you have servers that report when requests come in and out. They propagate application logs and report the state of the infrastructure. Some systems, like Nginx, are especially well built to handle that ingress. They just forward information to a tool, they can decorate the request, and they forward it out to whatever other systems may want to use that unstructured data. Search tools can drown when you give enough information to them, as we know. So if we were able to just dump our logs from Nginx into Elasticsearch, we could very easily overwhelm it. And that's usually where you put something like Logstash in the middle. But when we did start using Logstash, we would morph into this, where Logstash can still be regularly overwhelmed by the sheer volume of calls that we made to it from our infrastructure as events happened. We had big surges, what have you. We had 100 machines, and that would sometimes not even be enough. But we couldn't scale up indefinitely. There was simply too much data being put through, and the burden was too high on maintaining the infrastructure. Even more upsetting was if we had a site issue, we had errors happening, we had a bad deploy. We might wind up with something like this, where we're not only overwhelming Elk, we're overwhelming the tools that we use to monitor incidents. And unfortunately, this would happen quite regularly when we were having issues with applications and infrastructure. The failures from our applications would send more logs than normal, which meant Nginx worked harder, which meant Logstash and Elastic worked harder. Eventually, everything's underwater and we have a really hard time knowing what's going on. Our ability to read logs could be delayed by 10 minutes or more behind what's happening in real time. When Tremor was built, this was a critical problem that we needed to solve. Nginx can do its thing, right? Where we expect it to be able to push a lot of logs from a lot of places into Tremor. When we configure our Tremor server, we might decide that we want to ignore some of those messages, and we can do this in a couple of ways. We could identify if some messages look like a lot of other messages and they're redundant. We could decide that we're getting simply too many from a particular host or from a particular application. In other words, we can rate limit and normalize this data using Tremor. So knowing that the max that Tremor will usually handle is about 2,000 requests per second, we can split that up between all of the services that we listen to, where we might have 500 going to one service and 20 to another. We can ensure that we have that consistent performance on parsing logs by setting this rate limit. To give an idea of how much data can be used in these requests, we were able to stress test our Tremor infrastructure during Cyber 5, which is Thanksgiving to Christmas time in e-commerce. During a Cyber 5, I won't specify what year, Tremor was able to process about 5 gigabytes per second. And I'm not going to bring out log again because log is a whole terabyte, and cutting up log further would lead to some strange visuals and might upset the children in the audience. Let's try to use a measurement to get an idea of what 5 gigabytes is that isn't about log the cat, but still sophisticated. 5 gigabytes is enough data to watch Cats the musical twice, every single second. And given that Tremor is able to effectively parse, rate limit, and send requests onwards, we can keep ourselves informed without crashing our monitoring logging infrastructure, even with this sheer volume of data. There's a couple other reasons why Tremor works well for us at Wayfair, but these 2 points, the expense of the infrastructure and the ability to trace what's happening, were some pretty big wins for us. Particularly because it allows us to shield these downstream applications in a way that we could not before. I want to note for the sake of this presentation that I did actually watch Cats. The takeaway is on the slide. You're welcome. You don't have to watch it. Instead of streaming the logs directly through a filter, we can run them through Tremor. With rate limiting and streaming into different services like Kafka, Elastic, and other Wayfair services, we can send metrics, events, and telemetry to many places without maintaining a massive footprint. The ELK stack, or, well, it's not log anymore, so I guess ETK or KET or TEK, tech. Yeah, tech, that sounds good. That's not confusing. Our tech stack will allow us to know what's going on with a filter and rate limiting configured per application and per service and even per host, so that we can be sure that we don't overwhelm our downstream processes. Tremor then stands as a defender of requests by gracefully dropping information, decorating information, and rerouting what needs to go where. It is a courier, it's a guard, and it's pretty cool. It works at a scale that we need for enterprise e-commerce site. All right, I've teased it long enough, talking about the scale and the infrastructure and the changes and the advantages that we get. Let's take a step back and look at what our Tremor footprint actually was. By the time that we had eased over from Logstash and gotten similar workloads running on Tremor, we were able to cut down our infrastructure dramatically. Remember that we're still processing the same data, about 10 terabytes per day, but in Tremor with Rust instead of Logstash with Java. We cut down from about 116 core machines to 8 4-core machines, which is a pretty dramatic drop in footprint. What I'll note is that the estimated cost for running similar workloads on Tremor based on the rough outlines of our infrastructure goes from $40,000 to less than $1,000 a month. We are using the cost savings to start our own spaceline, Wayfair Galactic. Please stay tuned for any details on Wayfair Galactic. By saving money and being able to show that it is substantially compelling, being able to show this data is substantially compelling to a lot of business decision makers. As it should be expected, the Tremor team, being technical contributors, did not build it exclusively to persuade decision makers at the business level and to save the money that it saved. We found some advantages, and the nice thing about having a small footprint is that developers themselves feel more empowered to try Tremor and to put it in even smaller situations and more robust problem solving. Let's see an example. We found that the way Tremor, as one developer puts it, sips resources has allowed for some exciting use cases. Namely, it's possible to incorporate it as a sidecar along a Kubernetes application. For any of us that aren't intricately familiar with Kubernetes, a pod is what normally contains an application. We provide pods with some configuration and a container. If it suits the situation, you might even put a sidecar like Tremor to process the output of the application alongside your container. The advantage of this approach, instead of hanging up a big Tremor server and piping a bunch of apps to it, is subtle. But note that in a situation where a Tremor host is managed, a team would likely have to coordinate with many application owners to configure and deploy changes to that server, and that configuration file might get large and unmanageable and cause problems. By providing something alongside a Kubernetes application configuration, developers can be trusted with their own Tremor configuration file. That's reducing centralized server operations, and it leaves freedom to configure at the application level and the freedom to dynamically configure infrastructure. This model is interesting and exciting not only for the more cloud-native model of decentralized ownership in application containers. While that is certainly exciting, we're also able to limit our application's output. If errors begin spamming in from critical failure, we can reduce network latency from many requests because we can rate limit at the application layer. We're also able to flag incidents more effectively downstream, since nothing becomes overburdened but the application pod itself. Our Kubernetes monitoring and tooling can identify this spike without sluggishly plowing through log files at the same time. All right, so that was a lot, but let's talk about what's next. We've talked about where Tremor came from, some of the cool ways that we use it, and the savings to be found by adopting it. I'd like to continue by recognizing what we still want to do, what's exciting on our near roadmap, how you can get involved, and how you can stay involved with Tremor. One thing we think we can improve about Tremors is an ability to scale. That's confusing based on what I said earlier. I mentioned that we built Tremor to process events at scale, so why exactly are we talking about scaling? Let me explain. I want to start with this diagram that I hope feels nice and familiar, since we just saw it 2 slides ago before the spooky skeleton. This shows how Tremor is deployed, sips resources, and how we can co-locate it with our applications. This is certainly a valid and meaningful way to process logs, but there's a problem that we run into as the app scales. If you've designed an application well and maintain it as it grows, going from 1 box to however many boxes we may need is not a problem. Giving each one of those apps a sidecar is one way to handle the application. Like every technical approach, it has trade-offs. What if we're wasting compute and RAM deploying to every pod, where 1 Tremor instance routed to by every app will do? I mean, that would mean that we have 1 big ol' Tremor. Fantastic. It's strong, every pod is happy. I'm sure folks hearing this talk, though, are familiar with the differences of vertical and horizontal scaling. Where vertical, we're giving 1 instance a lot of resources, or perhaps a couple of instances a lot of resources, and horizontal, we provide more instances. When we mix those things, we run a pretty significant risk. Tremor might work harder. It might slow down, it might have strange behavior we don't see at other scales, and these errors can be difficult to replicate. We may hit the limits of infrastructure when more than 2,000 requests are coming in because there's more than 2,000 pods. Maybe there's a virtual private cloud that has trouble routing the networking traffic. As we've said before, there's upsides and downsides to every approach. Making one-to-one instances and making big ones are 2 approaches. But to target the issue of wanting to scale without deploying Tremor everywhere and without overworking 1 machine, there's another solution that we have in mind. With some adjustments, we believe that we could use a protocol like Raft to run Tremor in a cluster. If you're not familiar with Raft, think of it as a way to ensure that we have consistent transactions across the log consumption cluster. We'd have to be able to elect Tremor nodes to different roles to do this. So some nodes would become bosses and some would become workers, and the ability to build that consensus and communicate with one another, compliant with an algorithm, takes some time. It's on the horizon, and I think it will help us solve greater problems. But our vision for being able to scale effectively is hands-free and human-free in an ideal world. We'd like to get to a point where we can introduce more nodes and more scale while maintaining consensus. This, like the other approaches, has some drawbacks and advantages, but given that it's a modern approach and a solution to clustering, we want to provide it as another option for people running Tremor, but certainly not as the only way. Let's move on. Like any good open source project, we also want to be able to scale our community and get in touch with other projects. One of the best ways to do that is to identify projects that have a similar mission. Given that we collect a lot of data, inclusive of telemetry, metrics from other applications, we've noticed open telemetry as a path to including more projects and functionality out of the box. Open telemetry allows us to create and collect telemetry data from services and software. That's exactly their pitch. What that means is that it will be easier to view signals, logging, and metrics because many other frameworks and ingestion engines will be designed around a similar API that we can use. It's worth noting as well that, much like us at Tremor, OpenTelemetry is a cloud-native computing foundation sandbox project. That means that both us and OpenTelemetry are in the early stage of being in the cloud-native community, before incubation and fully matured projects. Kubernetes is an example of a fully matured project that went through this incubation process. Perhaps most importantly for this integration is that we think the community would grow around Tremor when it's compatible with other applications. Knowing that big frameworks like Express, Spring, and .NET support OpenTelemetry makes us feel confident that it's worth supporting ourselves. This would be a poor open source community talk if I didn't wrap up towards the end saying how you can get involved. I'll start out by saying we have a Discord community that is growing strong. You can join at chat.tremor.rs on the slide. We have folks all over the planet that ask questions, talk about Tremor, and talk about other stuff like cats, video games, Rust projects that we keep our eyes on. And the Tremor team makes themselves available for office hours every monthly on Tuesdays, I believe, but check the community for details. You can join by typing the URL into your browser, or let me know that you want an invite and I'll send it along. Secondly, you can, of course, log on to GitHub to start contributing. We have a backlog of issues, marked appropriately for veterans and first-time contributors. The team is exceptional at providing support and guidance, and you get to write some cool code along the way. You can also feel free to contribute an issue or discuss what you think you need. Lastly, check out the docs and talks site, tremor.rs. This talk will likely wind up there, along with plenty of other content if you're like me and you want to watch a lot and read a lot to understand how things work. Whew. Wow, what a whirlwind we've been through. Let's review. We talked about why Wayfair built Tremor and some of the ways it helped us along. We saw the cost of infrastructure when we used Elk and the savings that the Tremor stack, brought. We learned about the scale that Tremor can handle, which is 5 gigabytes per second, 10 gigabytes per day, still sipping resources. We learned about how Tremor looks in the future and how we're looking to open telemetry and clustering with the Raft protocol. If you take anything away from this presentation today, I hope you feel that it was a worthwhile investment of your time. As always, you can reach me on the Discord community. I'm Gary, or you can email me at gwhite@wayfair.com. It's been my pleasure to host you in this recording, and I hope you have a great rest of your day. Should I have the stream up to do the Q&A?
That's okay. We have questions pre-recorded. So my apologies. This Q&A started off horrible because I gave Gary the wrong link. First fuck up of the day. I'm not supposed to say that. Sorry. First screw up of the day. Anyway, first of all, thank you, Gary, for taking the time to make this awesome talk and now to be around on the Q&A. Do you want to give people a quick introduction, who you are and what you do?
And should we just
Sure.
pause here?
Hey everybody, I'm Gary White. I work in enterprise software. Most recently, I've been working at Wayfair.
All right.
Yeah.
So it is
I mean,
important
you
to know-
can keep the video there if we are running out of questions. We just listen to
Yeah.
pre questions.
I was going to say it is important to notice everyone, Gary has an amazing collection of sneakers.
Yeah, he sneaks into every just following up with all the dad jokes. I'm a triple dad, so I'm totally into dad jokes.
A triple
That's
dad.
awesome.
I have
Dad
3
cube.
children, and I was like, I won't tell you how I interpreted that.
Those aren't even my shoes.
I don't know. I'm not a native speaker.
those
so I
aren't
don't know what this
No.
dad idiom here. We just call them flat jokes, as like subpar. They are really flat as the ground.
These are my fiance's shoes, just for the record. I do not own this many shoes, and most of those are women's shoes.
Yeah. Everybody says that on the internet, Gary. Good. I have a question.
Sure.
So does Tremor do any pre-processing, like extraction of some metadata or adding some, can you also do rate limiting on some more advanced stuff, or is it just like, I've seen enough, don't bother me?
So that's a good question. Using the Tremor scripting language is how we do the rate limiting. So we can find queries that are coming from a specific place or have a certain piece of metadata and just choose not to send that anywhere. So anytime that you are giving data or anytime that you're getting data and then trying to push it forward, that's not an automatic process in Tremor. You can write it that it's just like a throughput and off ramp, and you only like say, okay, this one came from this host, and this one came from this host, and this one came from this host. But normally you would see the data coming in and then make a decision about where it goes. And since you're making that decision on the Tremor host using the Tremor scripting language, you have all of the capability that is available within that language, which includes extracting information, which includes decorating that payload before it goes to another place. It includes translating payloads from one on-ramp to a different off-ramp. One thing that I mentioned in the Open Telemetry talk that is going to KubeCon, come see me if you'd like to hear more of my radio voice, was that Open Telemetry is very popular because it standardizes how we get a lot of the information from our upstream signals. One of the things that it notes that it has difficulty doing is processing logs, because logs are just inherently unstructured data and they're very large. You can use Tremor to make those logs a little more readable and perhaps send them to places that Open Telemetry can use them better. Particularly when you use this as a sidecar, it can be very, very like strong and pertinent. If you're dealing with noisy applications that send out logs and you really only care about 35% of the logs that come from it, you can stop that before it goes literally anywhere, before it causes network congestion, before it does anything. So yeah, to answer your question in one word, yes, you can decorate and extract information from those payloads, and then you can send it along to wherever it needs to go.
Yeah. And is there already a wide variety of script examples and stuff? Because I think that's one of the main advantages of the Elk stack, that and Logstash in particular, or these bleeps. I don't know what they're called from Elastic now. That you already have stuff available for Nginx, Apache, and a myriad of services that you would want to monitor, so you don't have to start from scratch.
Mm-hmm. Yeah, so we do have a pretty active Discord community, which sometimes people interact with, sometimes people don't. There's definitely not as much of a Stack Overflow presence, I'll say that. That's coming up, but it's taking time for people to ask those questions and for people to answer them. We absolutely have a support network in office hours. We have documentation, we have stuff like that, but I think that Elk having the footprint that it has had in the enterprise for as long as it has, it would be disingenuous to say that we have the same variety of answers available. The capability is there, but the examples are probably not as numerous.
Okay.
Any more
questions?
I see one in the chat. Do you use Tremor as a sidecar as a way to look for security fingerprints? No. Because I think that requires sending another request out to go and check that this particular fingerprint matches some identity. Given that Tremor is a processing tool that I guess in a way, but perhaps not in the way that you're thinking about it, because we do have to do some fingerprinting when it comes to sending like information into GCP buckets, for example. There is something that helps Tremor keep track of where that's coming from and make sure that it goes to the right place consistently, instead of, we get man in the middle somewhere and then we're sending delicate information somewhere it shouldn't go. But that's like a pretty bespoke process, not something that I would say is like a default implementation of Tremor. So yes, we do use it, but probably not in the way that you're thinking about when it comes to footprints. I also see there's a couple of questions that I just want to check. Is the video from earlier also published somewhere? I went hunting, but wasn't able to work out appropriate keywords to find it. Let me send a link, because I had it to the YouTube playlist. I'll send it in the chat here in a second. While I'm looking for that, do other people have questions?
I have another question, which is, I know Wayfair has interns, a lot of interns too. Is this something that students are able to, come up to speed on fairly quickly, the scripting language? Or is it the kind of thing where you really need to be spending a lot of time to get used to it before you can get results out of it?
That's a great question, and I don't want to oversell it by saying that by saying it the way that I am, but I will say that we generally have data analysts that pick this up as sometimes their first scripting language to be able to process this data. It's certainly not something that's like even as complete as Python when it comes to what you can do with it. It doesn't stand by itself. It is absolutely a Tremor appliance. but I do believe that it, I mean, it's written as Rust macros, so it was all basically processes that were written as functions. And as a byproduct of writing those functions for the audience that we did, which was a lot of data analysts, people who maybe don't code as much as we do, we wanted it to be accessible to them. That being said, we also have some configuration management professionals that work on the Kubernetes layer that use Tremor pretty comprehensively for processing Kubernetes logs. So there is a lot of power to it, but we do want it to be easily accessible to people who maybe haven't coded before or aren't super familiar picking up languages.
Cool.
And there is the playlist link. That'll put you in the TremorCon playlist. There's a whole lot of other content in there, but that link is directly to my talk. If you want to learn more, it's a great playlist to watch.
So how is the scripting language compiled? I mean, if you're going to try to do this huge rate, I imagine it's not interpreted, it's compiled somehow. And how do you change the rules on the fly?
So when we set up a Tremor application, we actually need to use a configuration file to set up on-ramps and off-ramps. That configuration file is read at startup, and then you have to restart the Tremor server to have it read that configuration file. Those on-ramps and off-ramps are what will allow you to use a Tremor script in the middle, where you would say, here's my on-ramp, here's my processing step in this script, and here's my off-ramp. And so all of those things are put together when the Tremor server starts, not any time before that. So we're not like compiling it into a binary and then using that to run our processing pipelines. We're actually like taking that config at runtime.
So how do you switch out a version without messing up the pipeline? Like if I wanted to change the rules, how do I do that without shutting down the process or making a new config file and then shutting it down and then starting it up? I've just lost all these logs. How does that work?
So I would consider a blue-green deploy for something like that, where we can have two of the Tremor servers running at the same time, and then one of them goes down for maintenance, the other one takes the load, comes back up for maintenance, and then you switch the other one at the same time. That's more of a deployment methodology than it is like a Tremor specific implementation, I think, because like that's the constraint that we've decided to take as a trade-off. That particular use case, like, can I just hot replace this config file? I don't want to say that that's possible because I'm pretty sure that we store that in memory, but yeah, that's as much as I'll say about that.
So the scripting language is basically pre-compiled little procedures that are in Rust, and you're adding parameters to them, and then you're stringing them together as part of the language, right? So that gets you the speed that you need. It's not running an interpreter underneath that's doing the comparisons.
Yeah, so when we're using Rust, we have access to Rust macros, which are like very special little functions that you can use in a lot of interesting places. There are Rust macros that run only at compilation time, and so that will change the structure of the executable that you get. There are Rust macros that you can run as basically just-in-time compilation, which is what we're using here for Tremor, where we can interpret that macro because it's written in the way that we've written it, so that we can run those functions against the server and use the inputs that we've built into the processor to put it like in really high level terms. To get like really into the details, I think that it would be good to probably talk to the folks who wrote every single one of those macros, and that would be in the Tremor chat.
I have another question.
Sure.
We just recently, so OpenShift moved from using Elastic as the storage engine for their logging system. I don't know if they actually moved to Loki yet, but they are considering it. And in this operate first environment that we have up and running, we're using Loki from Grafana for storing the logs, because that was one of the research areas within Red Hat and the community. So I guess my question is twofold. Do you also have experience with storing it in Loki as the storage engine? And would I get any benefit from, except for I guess, no, it's just one question. Just answered the second question myself.
Sure. So do we support it explicitly? No, but I do know that we have a generic on-ramp and off-ramp that uses HTTP and whatever the Kafka thing is. I think it can use HTTP. But when we have these kind of use cases that keep coming up, like Loki, people tend to be able to just write the protocol that they need into their off-ramp as like, this is my HTTP, this is the endpoint I need to use, here's my bearer token, and then it can send the information along. But that being said, we did build it to be extendable. If you think that Loki should be a part of Tremor, then we are more than willing to help along and perhaps make that contribution.
Yeah. I think we're not directly ingesting into Loki, but via Vector. Do you know Vector?
Nope.
Which is, I think it's a similar system where you can basically direct logs from one input into another one. So maybe that might be interesting to find out. So that's like my second question. Operate first, this community cloud is also about long-running deployments where we can introspect from a community point of view how certain things work together and have long-running demos and find out how it would integrate with another system. Let's say we have Loki and we have Vector, and then just have the direct comparison with like Tremor feeding into Loki, or Tremor feeding into Vector and then into Loki or into Elasticsearch. And that comes with a investment from the community for deploying these things, and then also a little bit like maintaining them and always keeping them up to date. And what you basically get back from a community perspective is a live deployment of something where the community can actually introspect these things and with like play data in air quotes, but also it's still production data because it's still running substantial workloads, right? So my question is, A, do you have such a reference implementation demo environment for the Tremor community, or would you be interested in being part of this Operate First community and deploy stuff there and see how it performs with Kubernetes logs, for example?
Yeah, we don't have one of those just hanging around. I would definitely be interested in being a part of that.
That sounds good. Then expect some emails and my bank invoice account numbers to bribe me.
You got it, man.
Yeah.
All right. Any more Q&A? This is all great. Thank you so much for all the great questions.
So Gary, is there a way for folks, a preferred way for people who are going to watch this video after, because it sounds like there's a fair number of them, to get in touch with questions? Or would it be helpful for us to set up a Slack channel or something as a place for people to interact with you?
Yeah, I'm fine with email. I tend to keep my email open and try to keep as close to zero as I can. If you want to also invite me into a Slack, I think they do the easy shared Slack thing now, and you can use my email address as linked to my Slack account that I check for.
Oh, cool. Okay.
One more question. Do you only do logs, or do you also look into like gating events or traces and all the other data that might be emitted from systems?
It's a great question. And I specifically worked on logs for this talk because the live laugh log was just too good of a pun not to do. We do process any other kind of signal that can be coming in from, as you mentioned, traces, you might get metrics, you might get counters, all of the stuff that I know we have somebody that works on open telemetry in this group. Unstructured data is unstructured data, exactly. It gets forwarded along, and yeah, we support our use cases pretty robustly, and we support like a general use case of like, here's the open-ended version of all of what we do. And then that works not just for logs, but we can decorate things like spans, traces, and other metrics.
Cool.
What do you mean by decorate? Does it mean like you add extra fields to here's a record, you add more fields and then you send it to the output? Is that what you mean by decorate, or is this some sort of metadata extraction and you send that as a separate, create a whole new record versus adding stuff to the old record? Maybe that's
both of those things. And let me give an example of each. So we have one of the things that we noticed at Wayfair is that a lot of people like to throw extra metadata into this thing called slush, where we have like a slush field at the end of most of the things we would send into Elasticsearch. And that would be where developers put all of the weird data that they want to know about. So they'd put version numbers, get hashes from their applications, stuff that they wanted to know so that they could relate requests to one another. And instead of doing that, we were like, well, why don't you set up this Tremor on-ramp and contribute to the script so that you can say, if it comes from such and such kind of host name, then I know that it's this kind of the application. And then you can deploy that alongside whatever changes it is that you need. Remember that I'm talking about when you have a Kubernetes sidecar, you can change that Tremor configuration bespoke for every single deployment of your application. So I can put my information into Tremor, and then as Tremor is configured to do so, it can say, okay, I am this version of this application, and it's actually embedding that in the metric and in the trace instead of in some random slush thing that's more easily accessible from the developer angle. We do that because it becomes cumbersome it was cumbersome for some of our developers to interact directly with things like the Logstash API that allowed you to add extra fields on, the Elasticsearch API that allowed you to add extra fields on. They felt that the Tremor scripting was much easier to decorate those requests with rather than putting them in the slush branch or the slush field. The other thing that we might do is we may extract information for reasons like PII, or if we have some kind of request that contains sensitive info, we can filter it out by default. I'm going to give an example. I'm not saying that we actually have had this happen, where if we have a log, for example, that's sending, oh, this is what this person's password is, even if that password is salted by the time it gets to us, why does it need to be included in the request? So we would be able to extract data that we think may be vulnerable or may cause problems, so that when it gets downstream, we can retain it for longer. There's less identifiability to it, and there's just less sensitive stuff that we have to keep under harder lock and key. Yeah, and I think now that it's gotten a little more mature, we've started trying to anonymize that data so that it's easier for us to do data processing and like learning against by training our models against things that aren't actually like customer data and aren't actually sensitive. So both of those things, we can extract some of that information out before it goes out on an off-ramp. We can also add some data in before it goes out on an off-ramp. And the cases for that are a little tricky depending on what it is that you want to do. But both of those things are totally possible. Sure. Bye, Sally. If you haven't left already.
Okay. Thank you, Gary, so much. So I think that was a funny talk. I like your way of your sense of humor. So, and thanks. We made it to the top of the hour or the bottom of the hour. At least we spent an hour here in this lonely room.
Barry, please tell me you're like doing a side hustle of voiceover work, because your speaking is very like calming and you're just so articulate and
yeah, I feel like I should now, because the secret is that you get a nice podcasting mic and then you just get in close and you just talk really softly and it works great.
I see Michael going, ooh, a fun toy.
Yeah,
right.
I had the thought, and then I'm like, no. Cool. Thank you so much, Gary. This was really, really great. I think it's going to lead to some really interesting, especially if we've got you and Marcel and connected. I think this is going to lead to some really cool places to run and use the software and play with the software.
Absolutely.
That's really awesome.
Yep. Excited to see what comes next. Thanks, everybody.
Thanks, everyone.
Bye-bye.
Bye.